Hello and welcome to the Tungsten Masterclass training, and in this session we take a deeper look into the working of Tungsten Replicator. My name is Chris Parker, VP of Customer Success here at Continuant. In this short course we will take a look at the inner workings of the replicator, specifically replicator roles and states and replicator stages. First, let's look at the replicator. Tungsten Replicator is integral to a tungsten cluster and, as the name suggests, is the process responsible for replicating the data. Tungsten Replicator is an asynchronous replicator and is installed locally on the database nodes along with the manager processes. It can also be installed as a standalone replicator, although I won't cover that here in this course in detail, but if you are interested, then I recommend following the Tungsten Replicator Masterclass after this. This diagram shows the basic flow of replication. The replicator can operate as either an extractor, as you see on the left, or an applier, as you see on the right. And within a tungsten cluster, this role is dictated and controlled by the managers, ensuring that when the node is a primary, it operates as an extractor, and when the node is a replica, it acts as an applier. Replication is transactionally consistent and serial. By that I mean that we only process a transaction for replication when the entire transaction is complete and committed to the binary logs by MySQL. The replicator converts binary log information into THL, or transaction history log, which is our own native format, pretty much like a binary log, but in a format that we have control over. The replicators in the applier role will pull the THL across the network and apply via JDBC to the target database. Let's review the various replicator states and roles. Typically, in a cluster, you would only ever see the replicator as either the extractor or the applier. However, other states can be useful in some situations. The extractor, or master, is the role the replicator runs on the primary and is responsible for extracting transactions and generating the THL log files. The applier, or slave, pulls the THL across the network and converts the THL into SQL statements, which are then applied to the target database via JDBC. thl-server is a special role that extractors can be placed into if the primary has been taken offline but a failover is not required. It enables the replicator to still serve THL to downstream replicas and allows them to be applied. thl-client is the reverse, and appliers can be set into this role. In this instance, the replicator will continue to pull the THL from the primary as it is generated, but not apply it to the target database. thl-applier was introduced in 7.02 and is the same as thl-client. However, where thl-client will not apply the THL as it is downloaded, thl-applier will. The replicator can go into many different states during runtime. Most of the time, these will not even be noticed by the operator or any monitoring, as they can be momentary, but others can be more informative and important to note. These states will be seen in the status output of the trep-ctl command or in the dashboard if it's being used. We cover the trep-ctl command in the next session. I haven't listed all of the states here in this slide. For a full list, along with explanations, I would recommend reviewing the documentation. Here I just cover a few of the key ones to note. Start. This is rarely seen by an operator, but will be the first state the replicator is in the very first time it is started. Depending upon the configuration, the replicator will either then go into online or offline normal, unless the replicator fails to go online, in which case one of the error or offline states may be displayed. Online is the normal operational state you would expect to see when the replicator is operating and healthy. Offline normal would be seen if the operator chooses to manually stop replication or if the configuration is set to not bring the replicator online automatically. Offline error indicates an issue has occurred. The replicator log files and the status output would need to be consulted for more detailed information on the error. Going offline is fairly self-explanatory and indicates the replicator is in the process of going into the offline normal state. Going online provisioning and going online restoring indicate the replica is in the process of either provisioning data following a startup or restoring data from a backup. The replicator will then progress to the online state if successful. Going online synchronizing indicates the replicator is preparing to go online, similar to the previous two commands. However, this is usually following a normal startup. If this state persists, then it is an indication that for some reason the applier cannot reach the extractor. This could be because of a network issue or simply that the extractor is not running. Online degraded is seen on extractors when we detect the source database as being unavailable. The replicator will continue to process any binary log information available and will then progress to the next stage. Online degraded binlog fully read indicates we have lost the source database, similar to the previous state. In this case, we have read all of the binary log information we have and that a failover is now safe to be initiated. Replicator stages. Each replicator has multiple stages, and these will differ between extractors and appliers. The extractor has two stages, binlog to queue and queue to thl. Each stage operates independently of the next, allowing maximum throughput and performance. Additionally, each stage can be tuned and also configured with filters. We do not cover the use of filters in this course, however we do have a session in the Replicator Masterclass series that goes into more detail. Binlog to queue is the first stage. This is responsible for extracting complete transactions from the binary log and placing into an in-memory queue. Queue to thl then takes the complete transactions from the queue and writes them down to thl on disk. The applier has three stages. Remote to thl is responsible for pulling thl across the network and storing locally. thl to queue will then process these thl files and extract complete transactions, placing them into an in-memory queue. Queue to dbms will then take these transactions from the queue, convert to SQL statements, and apply to the target database. Applier replicators can also be configured to use parallel apply. This can be especially powerful to maximize throughput in the cluster. However, parallel apply is not always suitable for every application. For parallel apply to be effective, your source database needs to have multiple schemas that your applications write to, and more importantly, transactions should not span across these schemas. You would typically configure the replicator with a number of channels. During operation, the replicator will then assign one channel per database schema. Therefore, if you have a very active database with 10 schemas that are also very active, then you could choose 10 channels as your starting point. In summary, in this session, we looked at how the replicator works. We reviewed the stages, states, and roles of the replicator. Thank you for your time. I hope you found this informative, and I look forward to welcoming you on another session very soon.